Last type of reaction we're going to take a look at is the combustion reaction. Combustion, one of my favorites. It's just a fancy name for burning. In order to burn something, for fire we need three things. We need oxygen, we need fuel, something to burn, and we need a spark, some sort of ignition source. The best part about a reaction, combustion reaction, aside from the fire, is that it always produces the same thing. You're always going to get the same two products. You're going to get carbon dioxide and water for complete combustion. Complete combustion is considered clean burning. So if you've got a car engine that's very efficient, burning its fuel cleanly and completely, you don't see a lot of exhaust. However, if you have incomplete combustion, on the other hand, always produces carbon dioxide and water. In addition to that, it produces carbon monoxide, a toxic gas, and solid carbon. That's the soot that you might see coming out of a car that has, that's maladjusted, that is in need of a tune-up. You see a lot of smoke pouring out of there. If you can see the smoke, that means it's incomplete combustion. But it's always these products for complete or incomplete. With complete combustion, actually with either type of combustion, don't be fooled into looking at this side, the product side, the reactant side of the equation. The reactant side will always have oxygen on it because we said that we would need oxygen for for a fire. This is our fuel. The fuel is typically a hydrocarbon, but it can be anything. So this is our fuel in each case. And again, we get our products. At first glance, these might look like single replacement reactions because I've got an element reacting with a compound. However, that element is oxygen. So don't look at the reactant side in order to decide whether something is a combustion reaction. Look at the product side. So this is your visual clue for identifying combustion. Visual clue for identifying combustion is on the product side. It's always going to be the same products, carbon dioxide and water for complete or clean burning, carbon dioxide, water, plus carbon monoxide for incomplete or dirty burning. If you have to predict the products, you must be told what kind of combustion you have. You can't predict what's going to be made unless you know whether it's complete or incomplete combustion. For example, let's say we took something like CH3OH. I believe that's methanol. Reacting with oxygen in, we would have to be told whether it's complete or incomplete combustion to decide what is made. Let's say this is complete combustion. Complete combustion, this is pretty easy then because I know my products are going to be carbon dioxide and water. And I'm done, except for the balancing, of course. Let's go ahead and balance this up. I've got 2 oxygens over here. I've got 3 oxygens over there. I'll save that for last. Oh, wait a minute. I've got 3 oxygens here. Yeah, this is okay. 3 and 3. Yeah. 3 hydrogens, 4 hydrogens. Oh, I only have 2. So let's try putting a 2 here. 1 carbon, 1 carbon. So then now I've got 2 plus 2 is 4 oxygens. 4 oxygens over here. It'd be nice if I could go with 1.5 of these. If I could go 1.5 of those, then I'd be balanced up, right? Because 1.5 times 2 is 3, plus another one is 4, and then my hydrogens and my oxygens and my carbons would all be in balance. Well, I can do that, but I can't leave that as a half. What I would do at this point is I would take and multiply this entire reaction by 2 in order to get rid of that half. So what I would wind up with is 2CH3OH plus 3 oxygens produces 4 waters plus 2 carbon dioxides, and I should be balanced. Let's double check this. 2 carbons, 2 times 1 is 2, 2 carbons. 8 hydrogens, 4 times 2 is 8 hydrogens. I've got 3 times 2 is 6, plus another one is 7 oxygens. Whoops. Plus another 2 is 8 oxygens, right? 3 times 2 is 6, plus another 2 times 1 is, that's 8 oxygens over here. I've got 4 plus another 4 oxygens, and it's balanced. So again, combustion, very easy because there's only 2 things I'm going to have to remember. Carbon dioxide and water, or carbon dioxide, water, carbon, and carbon monoxide. Again, clean versus dirty, or complete versus incomplete combustion. You would need to be told in order to predict the products, whether it's complete or incomplete combustion. I suppose we could do the same thing for methanol with incomplete combustion. Let's go ahead and do that just for kicks. CH3OH plus oxygen. I always need oxygen for burning, for combustion. So oxygen will always be a reactant. In fact, I mentioned that, but we should probably write that down just for clarity's sake. Will always be a reactant. All right, so if this is incomplete, that means for sure I'm going to get CO2 plus water plus carbon plus carbon monoxide. It doesn't really matter what order you write them in as long as you get them all on the proper side. Let's go ahead and balance this. This probably won't be quite as easy, but we'll try it. Yeah, I've got 3 carbons on this side right off the bat, so I know I'm going to at least multiply that by 3. Let's see what happens here. So 3 carbons, that's okay. That means I've got 4. That's 3 times 4 is 12, so it means I'm going to need a 6 here. So my carbons and my hydrogens are balanced. My oxygens, let's see, I've got 3 times 1 is 3, plus another 2, that's 5. What do I have on this side? I've got 2, 3, 4. Oof. Be great if I could just use a half of one of these then, wouldn't it? Yeah, so let's do this. Let's multiply this by a half. So then I've got 3 plus another 1, because 2 times a half is 1, so that's 4. And then on this side I've got 2, 3, oh wait a minute, oops, I almost made a critical error here. I've got 6 times 1 here. Ooh. 6 times 1 is 6, 7, 8, 9. I've got 9 oxygens over here. And this is 3, So I need 6, so this is going to be 3. There we go. Wow, I almost messed that up. Let's double check this. 3 carbons. 1, 2, 3 carbons. 3 times 3 is 9, plus another 3 is 12 hydrogens. 6 times 2 is 12 hydrogens. 3 oxygens, plus another 6 oxygens is 9. And I've got 2 plus 6 is 8, plus 1 is 9. Incomplete combustion. There we go. Balanced.